Good morning, good afternoon, good evening to our webinar Northbound Connectivity. My name is Detlef Maas. I'm working in the product management and responsible for ibaAnalyzer, ibaDAT coordinator, and also involved in all things which are related to databases, as I did this since more than 15 years now. I will present the PowerPoint stuff in this webinar together with Tobias.
Yeah, hi, also good morning, good evening, and everything in between to all our international listeners. So my name is Tobias Seitz. So I will assist my colleague that left today with some more or less hands-on examples about northbound connectivity. And I'm looking forward to the next hour. And let's start on with the details of the webinar.
Yeah, okay. So something about our playbook, so some rules. We have planned 60 minutes for the webinar today, and the webinar will be recorded, so you can see it later on. If you miss something, question can be posted directly to the chat, and during the presentation, all participants will be muted. At the end, we have a session for questions and answers, where you have the possibility to unmute yourself, and after the webinar you will receive an email with a feedback questionnaire, and it would be great if you give us some feedback that we have the possibility to improve our webinars. So let's have a look to the agenda. First of all, we will look for the definition of northbound connectivity in the IBA ecosystem. What does it mean? What does we understand regarding northbound connectivity? And then we go to details, and we start with batch processing or cold data and ibaAnalyzer, the ETL process, ibaDAT coordinator for the automation. And then Tobias will take over with a live demo. The second part concerns the ibaPDA functionality regarding streaming, server, and output interfaces, and we talk about hot data. So we look to ibaPDA data stores and interfaces, and also have then a live demo. The third part will focus on the ibaHD-Server, also the northbound connectivity via the API, or new, which is coming up, the OPC UA for historical data. And at the end, I will explain some stuff regarding topology, what about edge and on-premise computation and storage regarding the HD server, and then we came to the questions and answer part of this webinar. So first of all, let's start with a slide regarding the IoT reference architecture. And okay, let me check if I can move the mouse somewhere here. It's not going on. Yeah, now it's coming. So we start here normally with our IBA system. We have physical devices and controllers, and we have the connectivity. We talk about southbound connectivity here, and we have the edge computing and data accumulation. This is what nearly all IBA systems are doing. ibaPDA just connect to interfaces and then record data and store it, and store it in our own format. Then we have a layer regarding data abstraction, application, collaboration, and processes. And with these levels, we come up to northbound interfaces and to the IT level. So from the OT to the IT level, and in most cases, we are located in the edge area. So a lot of buzzwords. Let's go to the IBA area. So the IBA system and open ecosystem. We have a lot of types of data. We have production data, material data, process data, machine data, energy data, vibration data, and we have a huge amount of connectors for field bus systems, for AD things, connectors for PLCs. We have also connectors to MES systems, maybe with SQL interfaces, and we have also video data. And we have in PDA our first part. This is the IO manager, And the second part, I say always, it's a visualization. And the third part is the storage of the data. And we come to the right side, storage in our own format, the ibaDAT format, and in the ibaHD-Server. This is a part of data recording, and then we come to analysis. So we have our ibaAnalyzer, ibaDAT coordinator, maybe a database behind it, database on the edge level, or on the IT level maybe, and the ibaDavis. And here we have lots of stakeholders regarding the data. So people coming from the maintenance, this is the most common part, maintenance or commissioning with ibaPDA. We have production people, people from the quality department. Here we come more to requirements to transform data, to aggregate data, to do some computations before these stakeholders will use the data. We have process technology, R&D, engineering, or data scientists. So we have here the borders, OT network, IT network, and here we talk about northbound connectivity, and we have a huge amount of connectors. We have the connectors from or via ibaAnalyzer, ibaDAT coordinator, directly from PDA, and the access to our ibaHD-Server. On the left side, we call it hot data because from our measurement system, ibaPDA, we provide the data directly. So we are on the live stream, and on the right data side, we talk about cold data. And yes, let's have a look to this cold data or batch processing part. So we have here our connectors. And if we start here from ibaAnalyzer, we always say regarding the IT guys who talk about data warehouse systems, and so they're very common with three-letter acronym called ETL process, or extract, transform, load. And we have implemented this in our iba ecosystem with the extract, which means we have access to the raw data. We have the option to transform the data and load the data. Load the data to databases, in this example, SQL databases like SQL Server, Oracle, PostgreSQL, or to different file formats. And for the ETL process, in the second part, the transformation, this is very interesting because we can implement this via the ibaAnalyzer. And in this screenshot, we see ibaAnalyzer with example data coming on from a steel production process where we have a measurement series, a time series here on top, the blue signal, which is some thickness measurements. We have measurements from a speed of the production, and we have a validation signal. So this is the raw data, and on the left, where it's hard to see, we have around 50,000 samples for this example. So we have only a few seconds of in a DAT file, and we have 50,000 samples because we have a resolution of 1 millisecond for our raw data. This is nice for people from the maintenance, from the commissioning, but for quality, we talk about raw data. For quality considerations, it's not interesting to have the time-based data. We want to have the data in relation to the position of the batches of the material which is processed. So we have to transform to a different X scale. We have to transform it, in this case, to positions, to a length scale. So from the raw time data, we use the speed signal, and we have our raw signal, and we transform it to our length-based thickness profile to see if at every part of the strip, everything is under control and has the right value. And this is the second layer of data. And here we have around 1,000 samples because we transform it to a resolution of 0.1 meter. So from 50,000 samples in raw data to 1,000 samples in the process data quality level. And on the third level, we have only one single value. What we calculate here is the OEE value regarding the quality. So OEE is a typical KPI, have three types. We are focused here on the quality part of overall equipment efficiency. And we calculate here the OEE value and see one single value, which is about 99.5%. This data is interesting maybe for management level or for monitoring of the process. And we have these 3 different layers, and we derive all these values in ibaAnalyzer. So from the raw data to our transform process quality data and also to the KPIs. And this data we want to provide then via our Northbound connectivity, maybe to relational databases or to other formats. And yeah, let's look which we have here. And this was how I started in the past with extraction to relational databases, for example, to an Oracle database. And we have there the possibility we can also extract the raw data to a database. Then you should use a blob format to handle the huge amount of data. But in most cases, we use here a simple format which is readable, so to have our length-based data in the database. And this is a perfect interface for the MES system, so to provide the quality information for the manufacturing execution system, and there runs application maybe for product releases, everything in a specification, or should something be blocked. This could be decided there, and IBA provides the aggregated data and the transform data, the transformation to another level, which is interesting for this application. The third part are the key values. So we have only single values. Okay, here we see 3 tables. Normally we have only 2, or in the past we have 1. We have only the so-called file table, which means 1 value per batch. Now, since the new version 8, we have also some meta information, and this introduces the second table. And we have these 3 layers. For the file extract, we have several formats which we support. So one format is maybe, I hope you can read it, or we can go to full screen mode. Then, yeah, that's better. We have a ComTrade format, maybe for the people from the energy applications, or we have TXT files. And a format which become very, very popular is Apache Parquet, which is a format which is open and popular for data scientists and very efficient. If we provide the data, then maybe in the Northbound connectivity on premise or on a cloud system in the Azure Data Lake or in AWS S3 buckets. So the Parquet format gives us a possibility to bring a huge amount of IBA data, or to bring the complete raw data to another level and to huge storage system, maybe Hadoop or these cloud systems. So we have here our ETL process, but we use ibaAnalyzer. We derive the transformation in ibaAnalyzer. We do the configuration, but now something is missing, because we need a guy who press always in ibaAnalyzer the extract button. Since version 8, it's free of charge to do it interactively, but you don't want to have an employee who's always using ibaAnalyzer. So we need a tool for automation, and for automation we have the ibaDAT coordinator. The ibaDAT coordinator is an automation service which uses the configuration of ibaAnalyzer and starts the extraction batch-wise or in a time schedule. So we have so-called jobs in ibaDAT coordinator, so trigger jobs, event-based jobs, or in a fixed schedule. And this uses ibaAnalyzer, and there we do the extraction. But with ibaDAT coordinator version 3, we have some new functions, features integrated with ibaDAT coordinator. Now we have also data transfer tasks. So if we have as an output a file format, for example, Apache Parquet, we can transfer it to a cloud storage. Or we have here server interfaces now. We have the OPC UA server and SNMP server already integrated for monitoring, for health monitoring of the application, but we can provide also data calculated with iba Analyzer via these server functionalities. And now we have also integrated the iba Kafka in the iba Kafka store, that we can provide data to Kafka clusters via iba.coordinator. So iba.coordinator has jobs, which defines the schedule, and iba.coordinator has in a job several tasks. And regarding northbound connectivity, we have special tasks. One thing is the extract task to database or to file, which I explained a bit in detail. We have a scripting task, and we have a copy, move, delete. Copy means you are in the environment of SMB shares, which are limited especially if you have a secure environment, and between these different layers you cannot have SMB shares. But we extended with version 3 a lot, and we have now so-called upload tasks. Upload tasks means Microsoft Azure, means AWS, but also we have SFTP, we have FTP, we have WinSCP to upload the data. Another possibility, we have now a so-called publishing task. Publishing have 4 components. One is extract to database. Configuration is the same as for the DB extract, but you use only the file table, and then you need only the publish license, which is much cheaper than the extract license. And we can also provide data via OPC UA, SNMP, and also Kafka. Last but not least, we have the transfer task. Transfer task means we have a communication between 2 DAT coordinator instances. We call one DAT coordinator a server and one is a client, and we can configure which port is used, if we should limit the bandwidth for the transmission and so on, to have the possibility to transfer data in a secure environment from one DAT coordinator to another DAT coordinator. Okay, a lot of stuff. I think we should switch to a live demo, and Tobias, please go on.
Yeah, thank you, Detlef. So we put a lot of thought into this webinar and what to present you, and I would like to leave this presentation mode now for a moment and go into our demo system. Because you saw there's lots of different things and lots of possibilities, and so we decided to show you one example with all the possibilities. We just click through this because depending on your process, depending on your application, some of the techniques available are useful and others not, and it's really difficult to make one example for each. So we have here, many of you probably know this if they have seen IBA webinars before. So this is just a simulation of a galvanizing line. It produces dummy data more or less, but realistic data from such a line. And in the background here, you see a typical QDR installation actually. So the QDR is an add-on to IBA PDA, which provides you length-based data already during the recording. But so basically there are DAT files falling out of this process. They are stored on the machine. And since we're looking at the batch processing now, I would like to show you what you can do now based on these DAT files. And we already saw the iba coordinator is the automation tool. And I also would like to start here. So since we are processing files, there is a so-called DAT file trigger job, and you configure this job to take the files which are pouring out of your PDA system, and then on the task level you design what you want to do with these files. And I have several examples here on the left provided, just to show you what is possible, how it looks like in the configuration, and also how simple and easy these configurations can be. So let's go through. So the first one is called extract publish DB. Publish, as Detlef mentioned, this is the file table, so the KPI values or the computed values which go into an SQL database. And the configuration on that coordinator side could not be simpler. So you have to provide a PDO file where your calculations are in. So that's where the work has to be done. Have a short look. If you open this from that coordinator, yeah, so you will see ibaAnalyzer popping up with the predefined analysis. There's no file in here, but if you just open an example file, then we should be able to see the raw data and also the calculations done on the data. So this is the engineering part. So you work with ibaAnalyzer and all your computed values, you see them here as expressions. They are in here, and then you can configure within the data extractor dialog. You can configure to extract exactly these computed columns. In this case, it's a historical name due to the database interface. So these are the values which go here. And additionally, you could also, as Detlef mentioned as well, to provide raw data here. This would then be another configuration. But here are our computed values. An ibaAnalyzer does all the computations. And on the dot coordinator side, we just have to select the PDO and select the extractor database here. And there's an additional checkbox which says only computed columns, which is then the KPI only variant, which takes a cheaper license. The same values, which are, so this PDO here you will find now in several places. We just reused it because the concept is the same. You have computed values and want to publish them via other protocols. The next example I have here is a so-called Kafka task. This is a little bit more complicated just because of the technology. Yeah? So the Kafka cluster itself has lots of options, lots of possibilities to configure it. And so you have to take care on the configuration side for this as well. So there's a whole connection tab where you can set all your parameters and connection settings. And on the target tab, you will find a list basically of the computed values you want to provide into this Kafka cluster as messages. And yeah, I don't want to go into too much detail here, yeah, but you can also add additional metadata. You can add timestamps to your to the batches itself, which can again be calculated from expressions. And then yeah, you have additional timestamps compared to the ones when the message was sent, because the message is sent when the file is processed, which is not the timestamp you're interested in the end, but you're more in a QDR process interested in something like the cut time, for example. Yeah, so this is the same values we saw before go here into the Kafka. And now this is basically intentional looking more or less exactly the same, with the difference that the connection settings are not here. So this is the OPC-UA publish task, which also has this list of values which are just loaded from the PDO. So if you load a reasonable .dat file here in the back, sorry for that. So you will find a selection here to select the values you want to publish. And those values are then not sent actively to some other system, but they are really published by iba.dat coordinator, by the integrated OPC-UA server, which is configured here. And then all the values we provide here are then available under these tags computed values. And you see here below the value changes every time a new file is processed. And so that's the way you can provide computed values via OPC-UA. And now getting back to the raw data, so the file extract, also quite straightforward to configure. The same type of task, it's an extract task. And there's another option, extract to file. And there you can also put your analysis again, where the computations, if you want to do any, are configured. In many cases, you simply want to extract the raw data signals as is to the new format so that you can use it somewhere else, and just specify where these files go and some additional settings to make subdirectories. So that's if you've worked with iba.dat coordinator, I think you saw this before. So this is a file extract. And now for something quite new with the version 3, ibaCoordinator, you now have the possibility to not only store these extracted files locally on the .coordinator server machine, but also to upload them to third-party systems via various protocols. So here's a list, yeah, FTP, SFTP, SDP, and also to cloud systems like the Amazon S3 storage, where in this case the Parquet files are simply uploaded to our S3 bucket, which is called ibaParquet files in this case. And all the files extracted now immediately go up into this cloud system. So let's take a look how this, where these data go then in the end. So the database extract is in this case locally on the machine. And if we take a look at the corresponding table here, the file table, which is filled, you can, for example, look at these data with an SQL management tool, and you will find for each file which is processed. So this system has been running for a few hours now. So there are files processed, and you find the timestamps, and you find all your values here in different columns for each file. Get the coil ID to this. So you have the computed values in a database table available, and from here you can start over to use them in whatever system comes after this. So this is the SQL example. Now let's get away from this virtual machine, and now I'm just on the laptop, and here we can, for example, look now at information pouring out via OPC UA. So this is a simple OPC UA client here, and you can simply connect to the systems. In this case, it's ibaCoordinator. For the example later on, we will also see the PDA data, and you can browse here through the values available on the .coordinator OPC UA server, and next to several general information, you find the computed values again here, and you can see them immediately here and query them from the OPC UA server. And this value here will change once every time a file is processed. So it's not very regularly updated compared to the data up here. They are coming from PDA. We will get to that later. Yeah? So they have much higher frequency. The Kafka system, we will find similar values. So let's go into this one here. This is also, again, a simple client to look at what's going on our Kafka cluster. I have installed on another test system. And there are two topics at the moment. The one for the live data. We'll come to that later on. And then the KPI data, I called it. This is then filled by ibaCoordinator. And if you look at you can, in this case, live data is not so frequent. But if you look what's in here, we will find several messages. And one message here contains then information, again, our values, the KPIs we computed with the values and the IDs. The format here, what exactly is written into these JSON messages is configurable. Yeah? So this is just an example here to demonstrate that the values we computed are available also here in this system, and you can use them then with any Kafka consumer. The Parquet data, just to get to the last example. So if you look at here at the buckets in our Amazon S3 test instance, we will find some folders here. This is sorted by the day when of the upload. Yeah, so from today, there are lots of Parquet files filing in. These are uploaded by our .coordinator upload task. And so there are already 114 in. And if we would wait for a few minutes or more, then there would be the 115th file coming in after the next file is ready to process and processed by ibaCoordinator. Then extracted with Analyzer automatically and uploaded here to this Amazon S3 system. So that was a very quick overview. And yeah, so we have a question here. So that if the .file trigger job shown by Tobias, what would be the license needed to perform those 5 tasks? Good question. Let's look into the dot coordinator configuration. So there's 5 tasks configured. 3 of them are subject to the so-called ibaHD-Coordinator publish license. So the publishing to database KPI only takes 1 tag of the publish license, the Kafka and the OPC-UA as well. So you would need 3 publish licenses for this task. The extract is the license is called ibaHD-Coordinator file extract. So you would need 1 of those to extract the files here. And for the upload here, you don't need a license at all. So this is you can do this free of charge. So if you would upload only the .dat file, for example, then you wouldn't need a license at all. But for the extract the license and for the publish 1 for each task. I hope that answered the question. And now I would like to hand back to Detlef for the next topic, the online data.
Yeah, thank you, Tobias. And well, at the end, we will have another question and answer session. Okay, let's come back to our overview. Normally, I have only one slide, but playing around with this, you see it. Here we have our overview of the northbound connectivity. And on the second part, we will look to the hot data part, to ibaPDA, regarding streaming, server output, and output interfaces. And if we look for data streaming, it's possible to write high-resolution data directly, for example, to databases, which is very, very powerful. We have different trigger options there, and you should use it with care. If you do unconditional database writing there with a database data store, maybe you can write data in a 10 millisecond resolution to an SQL database, no run length encodings and so on, and the amount of data is exploding. So we are able to kill the network with this, and maybe also a database server. This is very, very powerful, and you should really take care which resolution is needed if you write directly to a database unconditional. Conditional, of course, you can handle much more data, and yeah, we have a fixed structure for the tables, and we can adjust the extract performance with bulk inserts. And we can also extract to time series databases. InfluxDB can be addressed directly with a little workaround. We can also write to timescale DB, and we can then also write data to Kafka clusters. And the difference between ibaHD-Coordinator and ibaPDA writing to Kafka means with PDA we are writing just time series data, and with the .Coordinator we write only computed values or KPIs to a Kafka cluster. We have here also in PDA very important and popular the MQTT brokers which we support, and also Siemens MindSphere. For these data stores, we have a file-based buffering implemented. So if there are losses in the connection to the target system, we have a buffering on the PDA level, and if the connection is up again, the data will be processed there. One moment. Then next, I have a screenshot for this. And then we have our interface, which is absolutely flexible. So we have our SQL interface. And for the interface, you have to specify SQL commands, and you can do everything there. You can write insert, update, delete, free SQL, which is compatible to the target database. And this is related, you see it here in the screenshot, by the @ symbol, which is related to the data from PDA. So this gives also a very high flexibility. Also for reading, I use this very often in application now to replace old techno-string text channel handling via TCP IP and so on. I'm connecting to a database of the MES system, reading the data, reading the setup data and everything to have it together with the measurements in my iba system. So the output interface, and we have also the server interfaces, which means OPC, the old-fashioned OPC, OPC UA, SNMP, and only for alarms we have this IEC 61850. Here we see a screenshot of the OPC server output, and of course we can use the OPC UA for monitoring, for health monitoring, same as an iba.dat coordinator, and extended via the Plus license to provide data. So before we come to the live demo, if we purchase iba PDA and iba Analyzer, do we renew the license annually? Well, we have our EUP concept, but we have EUP only in the PDA area, not for iba.dat coordinator. And maybe Tobias, you have some remarks, and you can take over for the live demo. Full screen, please.
Yeah, thank you. Okay, so here I am again. So let's jump out of the PowerPoint presentation once more and back into our test system. The PDA system here we saw before does not only produce DAT files on a regular basis, it also streams data online into other systems. So usually in the data storage status, you can see different variants. And so there are several configured, and I would shortly like to show you where this is done and what the differences are. So here, this all you see down here is usually configured in the data store configuration. There's the button up here. So live data, so the same you would write into DAT files, or here you see also an ibaHD-Server configured. So the same online data can go into an SQL database, for example, or also to a Kafka cluster. And if we look into the data store configuration, we will find on the Kafka example, we will find much similarities to the configuration we saw before in iba.dat coordinator. So it's not a coincidence. So the things you have to configure here are actually the same for the connection. The difference is a little that the topics you write to is the kind of information you write into the topics is a little different. So you have the typical signal selection here and can assign profiles. So in this case, I'm writing data here every 10 seconds to not overdo this here. And in the topics itself, you can again configure the format, the metadata which go with the data. And in general, it's very similar, just a different application. It's not a KPI value. We have a collected set of computed things, but just individual signals with the raw data resolution. And the configuration is for all these data stores in some way it's similar. So you specify some connections. Also for the database, depending on the database type, you have different settings probably, and you have to specify a table where this goes to. But in the end, you will find yourself selecting the signals again, which you want to stream into this database with an according profile. And so this is the data store configuration. And you can, if you add new ones, you will immediately see, depending on the licenses you have available on your system, the different possibilities you have. And if you would do this for MQTT, it would work in a similar fashion, actually, just with another connection to the MQTT broker instead of the Kafka broker, for example. So data storage. We can look at these data also again in our for example, the small Kafka example tool I showed you before. So now it makes sense to go to the live view here. And if we look at the live data topic, so we will see that every 10 seconds, that's our profile, there will be a message filing in, and the message contains the values of the signals we selected, plus additional metadata for each signal. Also, again, here, the format in which this JSON comes here is configurable, but you will find just the online values in here instead of the computed values, which belong to a complete time range or product in this case, a dot file. On the OPC UA side, we saw that before. We have the same. We're also providing live data via OPC UA server, and if we attach to this stream with a client, the data will be filing in here. The difference, we have to note that on the OPC UA server, data are not stored. So the moment you see a data point here, if you don't store it yourself, when you collect it with the client, the value will be gone. The Kafka broker, for example, offers some possibilities to store data over some time. So I know that there are people also using this in as a kind of historical data server that you really store larger time ranges and larger amounts of values. The configuration of these servers, this you will find in the IO manager. So we can have a look at this one as well. So under the general tab, you will find these servers down here, and also here, depending on the server you select, there are different settings to do for the server itself. So that you can specify different security policies and login policies that not everyone can see the data on the server. But on the other hand, you just have the tags here. And if you have this OPC UA Server Plus license, you're notified about this on top. And you have an additional tab here with modules. And from the modules, you simply select some of the signals you want to publish via this OPC UA server. The same for the other types of servers is really, the workflow is similar. And the third one, so there's also here the output interfaces. We didn't prepare an example for that, but you will also find that here in the IO manager, configure for example, the MQTT or SQL database output interface. So these are the options you have for providing live data with ibaPDA. And with that, I would like to give back to Detlef for the last topic for today, the HD server.
Yeah, thank you, Tobias. And now we come to the third part of Northbound Connectivity. And we ended up here. We are focused here. And we have to speed up a little bit, but it fits, I think, perfectly. We have two options here. We have the API possibility. API means you can read via the API to your PC directly from the ibaHD-Server, and can use this API in your programming, in your own programs, and have to implement it. The second part, which comes up, was the OPC UA for historical data, and this is also a possible connector to the ibaHD-Server. But I want to talk a little bit about the IBA architecture and about topology. So we were in the first slides always located on the edge in the OT network. But for bigger installation and also for other stakeholders, we need the data, the IBA environment, also maybe on the IT level. So one possible solution is just bring the HD server from the edge to the IT level and have the HD server located there. We can also bring up the DAT files. We should not store the DAT files from PDA directly to the higher level. We should store them locally and then transport them via IBA DAT coordinator, but this is very easy to configure. And with the HD server on a high level, we can scale it up. So maybe we have there also the possibility to use with a small database, the IBA Davis, to provide dashboards for the data, or for the HD server, we can create an environment with several PDA systems writing data to one central HD server, and this HD server provides the data for the users and maybe for further processing. So we can have a topology and we can scale up the HD server, I think, yeah, with maybe up to 50 terabytes or something like this. So it's scalable. It's not scalable like a cluster system with many nodes, but it's scalable like a Windows system, and we can handle there also a big amount of data. Or if you want to have it for a huge plant, maybe you need several HD servers, but this is also possible to implement. Yeah, with the HD server, I want to look here a little bit to the architecture, because this is a switch in the paradigm between DAT file and the HD server. For DAT files, we have always the file handling with our Windows browser and look where they are located, and we need a start and stop trigger if we want to have continuous data. We have files maybe every 10 minutes. This is the default of ibaPDA. With the HD server, we have a seamless data stream. We have seamless data and we have different aggregation levels, which gives us a lot of possibilities. One possibility is that we can define there also events, and we have no data redundancy. For DAT files, in many cases, we need overlapping and so on. With the HD server, it's not needed. We can navigate much faster. But we can also, in some cases, maybe replace the DAT files recorded. We did some attempt on this via the events, but there's coming a new concept. We call it time period concept. You can find the first steps of it in the current version of ibaPDA and ibaHD-Server. And this is a new concept for indexing time periods, which means we have a start and a stop trigger. And this is similar like the DAT file, and the configuration is similar as this what we have for the DAT file. So we can define so-called time periods, and these time periods, we can use the HD server to store them, but we can also use an externally SQL database. And then we have a very similar environment as for the file table and with the ibaDavis. So we become open for this, and this gives us a lot of possibilities. Maybe some of you have experiences if you define a triggered recorder and you make some mistakes in the triggering, you have to wait for the next part and the old data is not usable. The definition of time period can be done in ibaPDA, but we would extend it that you can do this triggering also later on via ibaDAT coordinator. So this is a big step forward to open it up and to have wonderful new functionalities regarding the ibaHD server. So customer benefit, the HD server is a single data source for time-based data. No data duplicates needed anymore. We are very flexible. Our data is available. And yes, we have no more specific recorder needed because we have the time series data and we need only the time periods for everybody. And maybe long-term, it could be a replacement for DAT files, but we have, of course, especially in the energy area for the application, we have requirements with very high resolution data, or also for the condition monitoring, for the frequency analysis, we have high resolution, I think, which are problematic at the moment with ibaHD server. But it's growing. So this was regarding the ibaHD server, and now we have again our overview, and we come to the last session, and maybe Tobias will join, and you can unmute yourself, and we are good in the schedule. We have 10 minutes now, and are there any questions?
So if not, so maybe I can also chime in one or two comments. especially for the one point I wanted to mention, I forgot to do this before. So the API of HD-Server. So we get several requests there. Where can we get it and how can we use it? So you have to be aware if you want to use the API of ibaHD-Server, so you actually have to program the client yourself. So if you're looking for some implementation of the API already, so you have to look at ibaDavis, which is the client we provide you, which uses the HD API to show HD data. But another client is currently not available. I would also recommend to look at the OPC-UA HDA server then once it is out for release. And yes. Any more questions or any questions at all?
Are there problems with unmute? I don't know. I hear nobody. No reaction. We have 74 participants. Couldn't be possible that nobody have a question. Maybe if the unmute does not work, you can write it to the chat. This was working. We had already 2 questions during the presentation, and of course we are also available after this webinar. Yeah.
Okay, anyway, I think most of you know us, and you will find our contact data also in the online, or you can contact us via the IBA website. So thank you very much for participating, and we hope we could provide some useful information for your next upcoming Northbound Connectivity projects.
Yeah, and please give feedback of the email you will receive now with some questions we have. For us, it's very important because this area was grown. We have lots of more new northbound connectors got during the last years, and we need feedback which are important, which are used in production, which are research project. What is the status? That would be very helpful for us to have your feedback.
Okay, then thank you so much.
Yeah, and
bye-bye. Enjoy your day. Bye-bye.